PDF. Save as. Okay. So now we can open this one, right? Okay. So here we don't have answers, we have only questions. So it is easy for me. Okay, now the first question is, so remember, I I don't want you to like memorize anything. That's why I'm saying that you can bring all your slides in printed form. That's why I'm also on the top of every question, I'm giving the topic and the lecture in which that topic is covered. So basically, I want you to understand the material, not memorize anything. Okay. So, okay, here is the first question. Convert this binary pattern as a signed binary number to equivalent decimal value. So start doing it on your notebook and you have 3 minutes to do it. And I will wait for everyone, okay? Like even let's say some 5 students says that they are done, I will wait for everyone to complete. So you have 3 minutes. Because you guys are solving exam today, I can afford to be a little bit relaxed and I can have my coffee. So go ahead and solve your exam. Solve the question. And if you have a question or if you have already solved, you feel free to send me a text in the chat box. So now 3 minutes are passed. Let's have a look at the solution, right? So, okay. So the most significant bit is 1, right? So it's mean that the weight of the most significant bit will be negative. And remember, I said it is a signed number. So when you will do the conversion, so I'm writing the weights from left to right just to because I feel more comfortable with that. So if the first weight is 1, so then the next bit is 0. So I'm ignoring it. 1 plus 4 because 1, 2, 4. I'm not writing 2 because bit is 0. 1, 2, 4. I'm not writing 8. I'm writing 16. I'm writing 32. I'm not writing 64. And then I'm writing minus 128. And when you will do the math, you will find minus 75, right? A student said that the answer is minus 53. After explaining the solution, do you understand why it should be minus 75? Okay, good. Everyone is fine with it, with this answer? Or if you think that it's not correct, let me know. Okay, so now let's move to the next question. So the next question is you have, it is again about side numbers. So what is the 2's complement? Okay, before we go to the next question. So on the exam, to get the full score for a question, you must show the steps which you use to reach the question. So for example, if in your answer you say only minus 75 and you don't show all this, then you will not get full marks. Okay. So you show your work or show your steps to reach the final answer to get the full points. Okay. So next question. What is 2's complement of minus 10 in 8-bit binary? Again, you have 3 minutes. We will wait. Let's wait for like 3 minutes to be passed so that other students can also complete. Okay, now let's go to the solution. So we need the 2's complement of minus 10 in 8-bit binary. So 8-bit binary, we first need to get 8-bit binary of 10 itself, right? So which is this one? If I read from like most significant, it is 0, 0, 0, 4 zeros, 1, 0, 1, 0, right? Then I get the 1's complement by inverting all the bits, which basically mean making inverting a 0 to the 1 and 1 to the 0. So I will get this one. And then I get the 2's complement by adding 1 to 1's complement. So when I will add 1 to it, so I will get, if I read from most significant side, 4 ones, then 0, 1, 1, 0, right? And to confirm, you can actually convert it into the back to the decimal and you will see that it is equal to minus 10. Okay. So any questions? No? Okay, then let's move to the next question. So the next question is about memory interfacing, right? And here you need to design an address decoder using NAND gate for an address range of 0xC3 to 0xD7. Okay, so start doing that and you have again 3 minutes. Okay, so again, 3 minutes are passed. Let's have a look at the solution. So the address range is 0x33 to 0xD7. So this is the lower limit. When you will convert to the binary, you will get this one, and then, double one, all zeros, and then double one on the least significant side. When you convert D7, you will get 1101 and 01101. So now what you need to look is the bits which whose values are not changed in the whole range, right? So you get these 3 bits which are shown in red color. So I'm labeling them as A7, A6, A5. So A7 and A6, they are 1, A5 is 0. That's why we first need to invert it and then make it an input to the NAND, and then we'll get this output, right? Any questions? Any confusion? No. Okay, one thing, when we say that we need to look at the bits which never change their values, maybe you can say, okay, this 0 is also not changing the value, right? But that is not true. Why? Because this is the lower limit and this is the higher limit of the address range. In between, it will be changing values. Like there will be case where, for example, if you have an address, if I read it from the most significant side, let's say 110, 1100, and 1011. So that address will also be within the range, and the bit will be, this bit will be changing value, right? So that's why we are not making it an input of the NAND gate. Any questions? No? Okay. Then let's go to the next question. This is like a descriptive question. What is main difference between Harvard and Princeton architecture? Anyone who want to answer can unmute him or herself and answer the question. Does anyone want to answer this question? What is the main difference between Harvard and Princeton architecture? Or wait a minute. Am I connected to Bluetooth? No, I'm not. So I should be able to hear you, right?
So
No, no.
the code
Okay, go ahead.
memory and program memory, or the data memory and the program memory are separate.
In which one? In Harvard or in Princeton?
In Princeton.
No, actually, they
Oh,
are separate in Harvard. And when we say, and this is not correct statement, completely correct statement when you say separate. Actually, data memory and core memory is separate in both. The difference is that in Harvard, there is a separate set of data bus, memory bus, and address bus for core memory, and a separate set of data bus, address bus, and control bus for data. So both have separate buses, right? But in Princeton, they share the buses, right? Let me read you the exact statement. Harvard architecture has separate buses, that is data, address, and control buses for data and instruction memory. Princeton uses the same set of data, address, and control buses for both instruction and data memory. So both have separate data and instruction memory, but buses are shared. In Princeton, buses are shared. In Harvard, buses are not shared. They have, each one of them have their own set of buses. Okay, is it clear?
yeah,
Okay, okay. So let's go to the next question. Uh, what is the next question? Okay, here is a programming question. Here is a programming question. So what will be the value stored in memory at address 0xF4 after the execution of the following code snippet? So you have 5 minutes to solve this question. Okay. Some students are replying to me with the answer. So if I'm giving you a thumb down, that just means your answer is incorrect and you can try again, okay? So I don't want you to like keep waiting and wasting the time, okay? Okay, so we are done with 5 minutes. So let's go through the solution. So you are first putting 10 in 16, then you are storing 10 in that memory location. Then you are loading 10 again from that memory location and putting in R17, and then you are incrementing it so it becomes 11. And then you are putting it back in the same memory location. So the value at that memory location will be 11. Okay. Yeah. Yeah. Good. Good. Uh, okay. Do you think that 5 minutes were enough to solve this question? Is there anyone who thinks that 5 minutes are not enough? Okay, since so no one is replying, so I'm assuming everyone is fine. The 5 minutes are good. Yeah, okay. Okay, so let's go to the next question then. Actually, I'm enjoying it more than the lectures. I don't know. Maybe it is you like doing the most of the work. That's why. Okay, so okay, let's go to the next one. Okay, so show the status of C, H, and Z flags after the subtraction of 0x82 from 0x94 in the following code snippet. Again, you have 5 minutes. Yeah, that is a good question. One of the student asked that is one of the values negative? Since I have not said that these are signed numbers, so by default, you can assume these are unsigned numbers, right? And by the way, in both of them, the most significant bit is yeah, no, not in both of them. So in 0x94, the most significant bit is 1, but in 0x82, the most significant bit is 0. Since I have not specified that these are signed numbers, so it's mean that they are unsigned numbers. So this is like default. Okay, if in exam I don't specify that a number is signed, then it's mean it is unsigned. So even in 0x94, although the most significant bit is 1, it will be treated as positive number. Now it will not have negative weight. What is the H flag? It is the half carry flag. Remember? Half carry flag. Okay. Uh, for those students who are sharing the answer, I cannot like confirm whether it is correct or not. Please wait until we see the solution. Okay, now let's have a look at the solution. So we need to subtract 0x82 from 0x94. You can convert them into the binary, and you will convert into the binary, you will get this number. Do you want me to walk you through the subtraction process? I don't think that you will want me, because it is pretty straightforward, right? How you know how to do the binary subtraction. So when you will do the subtraction, right? Okay, there will be no carry in from carry out from bit position 3 into bit position 4, or there will be no borrow in from bit position 4 into bit position 3. So that's why h is equal to 0. Half carry is equal to 0. Also, there is no carry out from the most significant bit position, bit 7, or there is no borrow in the most significant bit position. So that's why you expect that carry will be equal to 0, right? Yes, you are right. But remember what we saw in lectures, that when you do the subtract instruction, execute the subtract instruction, the microcontroller itself flips or inverts the value of the carry flag. So if like it should be 0, it will be set equal to 1, right? So that's why it is 1. Okay. And z is equal to 0. Why? Because our result is not 0. It is a non-zero result. The question says subtract, but the instruction is adding. No. No, it is not adding. See, let me I don't know how to. You want me to go to OneNote then? Okay. In the code snippet. No, the question says do the subtraction, right? And the answer is also doing the subtraction. Like you subtract 0 from 0, you get 0. I'm talking starting from the least significant bit. You subtract 0 from 0, you get 0. Then you cannot subtract 0 from 1, you get the carry from the next position. So when you get the carry, you get the carry with a value of 2. So the carry is always in base, right? So 2 minus 1 is 1. And from the bit position 3, since you borrowed the carry, so 1 reduced to 0. 0 minus 0 is 0. 0 minus 0 is 0. Bit position 4, 1 minus 0 is 1. Then bit position 5, 0 minus 0 is 0. 0 bit 6, 0 minus 0 is 0. And bit position 7, 1 minus 1 is 0. Code snippet of question. No. Can you please, if you still have confusion, please unmute yourself and you can talk.
Yeah, I was just a little bit confused because in the code snippet it says add R20 R.
That's correct. Okay. Sorry. That's correct. Yeah, yeah. Okay, here it should be subtract. Yeah, okay.
Oh, okay, that was just a typo.
Yeah, yeah, that's just
Oh,
subtract.
okay. Okay.
Okay, okay. Any confusion other than that? Sorry for that. Any confusion other than that? No? Yeah, so there was just this little trick that when you do the subtraction, the carry bit is flipped. Okay. Okay, so let's go to the next question now, which is the following assembly code correct? If no, correct and rewrite it. If yes, what will be the value of y and z after the execution of the code snippet? Okay, so Actually, let me take you to the solution one because I think I have modified their question. A little bit I have modified the question. So don't look at the solution. Okay. So here actually I simply replaced y and z with b and c. Okay. Because it is not correct to write y and z because remember these are the pointer registers. These are 16-bit register. So, but actually I wanted to use 16-bit, 8-bit register, but by mistake I wrote y and z. So I simply corrected. Okay. So read this question. So is the following assembly code correct? If not, correct and rewrite it. If yes, what will be the value of B and C? Okay, after the execution of the code snippet. So if you want, I can correct it here immediately now. So here you don't have Y. I don't know how can I correct it now. So replace Y with B. Yeah, and replace Z with C. Okay. So now look at the code and also in here, for example, you can also do the replacement in these statements. It's a mess. Actually, I don't want to show you solution. That's why I'm making changes here. And replace X with A because X is also a pointer register, which I didn't want to use. Okay. Now read the code and tell me like whether the code is correct or not. If it is not correct, point out the mistake. If it is correct, tell me what will be the value of B and C after executing the code. And you have 4 minutes. So if I'm giving you this thinking phase, it's mean rethink your answer. So seems like as we are progressing into the practice exam, it looks like less and less people are responding now. Uh, our question is becoming harder. So, okay, let's have a look at the solution, right? So R16. So what we are doing here is we are saying load immediate R16A, right? One of the students said that this is mistake. It should be LDS R16A. No, it is not a mistake. Why? Because what is A? I am simply saying equate A with 10, which basically means that anywhere in assembly where I write A, assembler will replace it with 10. So 10 is an immediate number, right? So 10 will be placed in R16. A is not the address of memory location. It is just a placeholder for 10, right? It is not address of memory location. So 10 will be placed in R16 and then I'm saying store R16 in B. What is B? B is actually address of a memory location, 1 byte, right? That is what the common directive does. So 10 will be stored in B, and then I'm saying store R16 in C, right? In static memory. So C will be also 10. Yeah. Yeah, that's correct. Yeah. Okay, good job. So no, Amna, your question is not, your answer is not correct. Sorry for that. Wrong. Yeah. Okay. And yeah, yours is fine. Okay. So let's go back to the exam again. Uh, CISC architecture. So this is descriptive question again. What do you understand from micro-ops in context of a CISC architecture? Anyone who want to share his or her thoughts? What is meant by micro-ops in context of a CISC architecture? So for example, in Intel processors, if you remember during the lecture I explained it, in Intel processor, for example, some instructions are broken down into the micro ops and then micro ops are executed, not instruction itself. First instruction is broken into micro ops and then into the then micro ops get executed. So what is meant by micro ops then? Okay, then I will go ahead and explain. So micro ops are basically indivisible atomic operations which cannot be divided further. So their purpose is like we divide the complex instructions into multiple smaller indivisible micro operations and then we execute those micro operations. So it actually helps us to pipeline those micro operations. So for example, if you have a complex instruction and you want to execute it, you cannot pipeline it, right? Because it is a big chunk, it is a big chunk of work which you need to do. But then when you break it into macro ops, so then in each cycle you can allow one micro op to enter the pipeline stage. Okay. So micro ops are basically indivisible atomic operations. Okay. Conditional branching. Okay, assume the program counter is address. Do I even have this question in my solution? I don't remember. Let me question 6. Why there is a mismatch between questions? Okay, let's then uh, follow the solution because there is kind of mismatch. Okay. So the next question is conditional branching, right? Uh, so list the name of flags that are tested for comparisons. That is for comparison of signed and unsigned numbers. So how you compare signed and unsigned numbers when you compare which flags are tested. First, when you compare the signed numbers and when you compare the unsigned. So again, it is a descriptive question. I'm just going ahead and answering it on my own. So far, when you compare the unsigned number, the microcontroller looks at Z flag and C flag, right? Remember when C flag is, for example, when you are comparing two numbers, let's say A and B. So what you are doing A minus B. So if now A is less than B, then C flag will be set. But if A is greater than or equal to B, then C flag will be zero. Then how we know whether A is equal to or greater than B? Then we look at Z flag. If Z flag is 1, it's mean A is equal to B. If Z flag is not equal to 1, it's mean A is greater than B. Okay. And same goes for signed numbers. So the approach is same, but instead of looking at C flag, we look at the S flag or the sign flag, right? Any questions? No? Okay. So this is going to be a bit interesting. So, uh, uh, the next question is about AVR IO port programming. So you need to write a program that continuously reads 8 bit values from port B and B and D and send the result of addition to port C. You must enable internal pull-up resistors on port B and D. Is everyone clear on the question? Again, I'm repeating it. So you need to configure port B and D as input ports, port C as output port. You read the value from two input ports B and D, sum it together, and put the result of addition on port C. And you also need to enable the internal pull-up resistors on input ports B and D. So write the assembly program for that. Okay. Go ahead. You have for this one, let me give you 8 minutes. Okay. And when you are done, let me know. I will see if majority of the class is like there are sufficient number of people who are done before 8 minutes. I will go ahead and share the solution. If you have any question or confusion, let me know. Okay, so we have 8 minutes past. Let's have a look at the solution. Okay, so first we are configuring port B and D as input, and I will encourage you highly to also put the comments when you are writing your solution. And for example, if a question says that you need to put the comments to get the full score, then it's mean that if you don't comment, you will lose the points. In this question, I haven't specified, but if I specify that you need to comment, then make sure that you are commenting your code. So first we are configuring port B and D as input. So we are simply loading 0x00 in R16 and sending it to DDR-B and DDR-D, right? Then we're configuring port C as output. So we are loading 0xFF in R16 and sending it to DDR-C, right? And then we need to enable the internal pull-up registers. How we do that? By writing ones. So we already have all ones in R16. So I'm simply sending R16 to port B and port D, right? Then I'm entering the loop. So I'm saying, okay, read the value from pin B register and put it in R16. Read value from pin D register into R17, and then add both a result and put the result in R16, and then send the result R16 to port C. And then I'm saying, okay, R jump L1. So it will be an infinite loop. Is it clear for everyone? Okay, there is a question. Or a comment. Yes, okay, good. Good. Okay, one thing. Do you guys think that 10 minutes are enough for this kind of question? I mean, is there anyone who thinks that 10 minutes are not enough? Okay, it's enough time. Okay, good, good. So actually what I'm doing is that I'm solving the exam, and let's say for me it took, let's say, 30 minutes. So I will give you 10 minutes extra. So if I solved it in 30 minutes, I expect you to solve it in 40 minutes. Okay. Next question, IO port programming. Again, consider two push buttons, B1 and B2, which are connected to pin 0 and 1 of the port C, pin 0 and pin 1 of port C. Also consider two LEDs, LED1 and LED2, which are connected to pin 2 and pin 3 of the same port, port C. Now write a program that continuously monitors button B1 and B2 in a sequence. That is, it first tests B1 and then B2. and it turns on the LED 1 and LED 2 when respective buttons are pushed. You must enable internal pull-up resistor or resistors on input pins. Assume push buttons to be active low, so which means when you press them, the input is 0. When you release, output is 1. And you must use bit manipulation instructions, that is SBI, CBI, SBIS, and SBIC as needed, right? So following is the control flow diagram for the pseudocode of the required program. Okay, let me try to somehow hide the solution so that you guys can actually not have a look at it. And so I don't want to corrupt your mind. How I can do that? Hmm. Okay, don't have a look at the solution. Okay, I don't know how I can hide the right side of the. So I have given you the control flow diagram. So first you need to configure the pins, then enable the internal pull-up resistors, right? And let me try. Yeah, I can hide like this. Okay. So first I'm configuring the pins and then enabling internal pull-up resistors on the input pins. Then I'm checking is button 1 equal to 0. If yes, then turn on LED 1 and then turn off LED 2. Then go to the check the status of the next button. Uh, is B2 is equal to 0? Yes. Turn on LED 2 and turn off LED 1 and go back to the start of the loop, right? If if button 1 is equal to 0, if this condition is false, go and check the second button B2. If it is also false, go and again check button 1. Okay, so you actually need to encode this control flow diagram. Okay, now go ahead and you have how much minutes? Again, I know I should give you like 10 minutes, but we need to also do other questions. So let's try to finish it in 8 minutes. And if you have any question, let me know. So when you are done, let me know, okay? We are running short on time. I want to cover a couple of more questions. So maybe I cannot give you 8 minutes. I will wait for 2 more minutes, okay? Today, do you have quiz? Let me check if the quiz is scheduled or not. Let me check the syllabus. No, no, you don't have quiz. Okay, it's fine. It's fine. You can solve the questions. Okay, let me go ahead and show you the solution because I said we also need to do a couple of more questions. So first, what you need to do is you need to configure PC0 and PC1 as input. So for that, we are using CBI clear bit IO bit instruction for DDRC0 and DDRC1, right? Then we are enabling the input internal pull-up resistors on these two pins. And for that, we need to write one. So in port C at index 0 and 1. So for that, we are using the instruction set IO bit SBI, right? Set bit in IO register, port C at index 0 and 1. Then we need to configure PC2 and PC3 as output. So for that, we are writing we are setting the bit 2 at bit 3 in the register DDRC by using SBI instruction, right? And then, so after configuring, so we were doing all this stuff, right, in the first block. So after that, what we are doing is we are entering into this control flow diagram. So here we are first saying skip the next instruction if the bit 0 of pin C is set, right? So if it is set, which basically mean the input is 1. So we are saying if the input is 1 on the button 1, then skip the next instruction. So let's assume the input is 1, right? So the next instruction R jump LED1 will be skipped, and the control will go to the next instruction. So here we are saying uh, skip the next instruction if the input on the button 2 is 1, right? So which mean it is not pressed, right? So let's say it is still 1, it is also 1, button 2 is also not pressed, so input is 1. So we skip the next instruction, and then we go to the next one, which is R jump B1. So we basically go back to B1. So we actually have followed this path: no, no, and then go back, right? Now let's say when we go back, we check again the button 1, and let's say this time it was pressed. So if it was pressed, then the next instruction will not be skipped, right? Because we are saying skip it only if the button is has value of B1 has value of 1. But if it is pressed, it has value of 0. So next instruction will not be skipped. So we'll go to R jump LED1. So where is R jump LED1? Here, LED1. What we are doing here, we are sending 1 to the pin 2 of the port C where we have connected the LED1, and we are clearing the pin 3 of the port C, right? So LED2 will be turned off, right? And then we are saying R jump B2, go to B2. So we actually followed this path, this one here, right? So we go back to B2 and we check it, test the value. Now let's say this time B2 was pressed. So if B2 was pressed, the input will be 0. So the next instruction will not be skipped because we are saying skip it if it is 1. if the button B2 button is 1. So we'll go to our jump LED2. So when we go to LED2, we are writing 3 on the port C. Sorry, we are writing 1 on the pin 3 of the port C. So where we have connected LED2 and we are clearing the pin 2 of the port C where we have connected the LED1. And then we say our jump go back to B1, right? Any questions here? I know it was a little bit tricky, and that's why I have given you this the control flow graph, control flow diagram to make things easier for you. Otherwise, the thought process is like a bit complicated. Okay. Any questions? No? Let's go to the next question then. So these next two instructions are kind of descriptive questions. So for example, what is size of jump, R jump, and I jump instructions? So jump is 4 byte, R jump is 2 byte, I jump is 2 bytes in size. What the hell is this? Okay, sorry guys. So call instruction. Uh, next question is about call instruction. What is the range of call, R call, I call, and EI call instructions? So in call instruction, we have 22-bit operand, so which means we have 4 M locations. I have explained you while doing the lecture how you get the 4M. It is actually nothing but 2 raised to power 22, which gives you 4 million locations. RCAL has 12-bit signed operand. So when you and signed operand and it takes jump relative to PC plus 1. So the range of a 12-bit signed operand is minus 2048 to 2047. So the location will be relative to the P1. The target location will be relative to PC plus 1. Okay. iCal has 16-bit operand. So 2 raised to power 16 is 64 K location. EICAL has 22-bit operand again, so 2 raised to power 22 is 4 million locations. Okay, consider the following code snippet. Okay, I know we are left with only 1 minute, but I will encourage you if you can stay for 5 more minutes because next question is kind of critical. It doesn't mean that I'm saying, okay, this question will definitely appear on the exam, but we have not covered this question until this type of question until now. That's why I'm saying stay here if you can. So consider the following code snippet where function A where function A calls function B after the execution of the code, what will be the content of the stack and the value of the register R16 and SP, right? Stack pointer. Assume that before the execution of program, SP stack pointer is pointing to 0x7F, right? Let me directly walk you through the solution without waiting for you to complete, right? So what are we doing? In function A, we are putting 10 in R16. We are putting 20 into R17. And here in the comments, I have given specified the address of each instruction, right? So I'm putting 20 in R17, and then I'm saying call function B, right? And after when I say call function B, now what will happen? So uh, initially, my stack pointer was pointing at what 0x7F, right? So when I say call function B, the address of the next instruction will be placed on the stack, which is what address 4. So the 4 will be placed here, right? And then the stack pointer will be incremented. So stack pointer will become decremented. So it will become 0x7E, right? And PC will go to the function B, right? So in function B, I'm saying, okay, first push R16, and then when I say first push R16, what will happen? Value of R16 will be placed on the top of the stack. Value of R16 is 10, right? So here I have 10. And then stack pointer will be decremented, so it will become 0x7D. Then I'm saying push R17. The value of R17 is 20. So it will be placed on the stack and stack pointer will be decremented again. So it will become 0x7C. Now after that, I'm saying put 20 in R16 and put 30 in R17, which is also showed here, by the way. And then I'm saying add R16 and R17 together. So since they are 20 and 30, the sum will be 50, right? So R16 will have 50. So then I'm saying push R17. Yeah, this is a mistake. Here it should be pop, not push. I wanted to have pop, but there is a typo. It is pop. So I'm saying put pop the value in R17. So what is the value? I will get 20 from top of the stack and it will be in R17. Then I'm saying pop the value from R6 from top of the stack into R16. So R16 will get back value of 10, right? And then when you say return, so what happens is that the top of the stack is pointing to 0x7f. The value on the top of the stack is 4, so it will be loaded into the program counter, right? So so what will happen that when your program completes, SP will be equal to 0x7f, right? R16 will be equal to 30, R17 will be equal to 20. Okay. And this will be the content of the stack, right? Any questions? No? I know I walked you through very quickly through the last question because of limited time, but you can again go through through the question on your own. And if you have any confusion or question, send me an email. Okay. Uh, the last question is straightforward. Solution is provided. I will leave it for you to go through it. Uh, it's pretty easy. Okay. So, do you have any questions before I sign off? Any question related to the exam or okay? Do we have lab next week? So actually, here is the thing. Your lab is, let me clarify this for everyone because students are asking again and again. Your next lab is, when is it due? It is due on, lab 5 is due on uh, 16th of October, right? So in between, you have like two lab. You have also labs are scheduled, like for example, on 10/09 and 10/14, right? So instead of like you what you need to do is you can use that time on 10/19 and 10/14 to do your lab work, right? So if and if you are like already done, you can show to the TAs and you don't need to go to the lab on 10/16, 16th of October. But let's say you were not able to do it on 10/19 or 9th of October or 14th of October, the weeks previous the due date, right? So you need to go to the due date and submit your lab. Okay. So that's why it is like it is your due date. If you are finished with the lab before the due date, you don't need to go. If you haven't finished yet, go and show your work to the TAs. Any other questions? No? Okay, then let's stop here and have prepare well for your exam. I wish you good luck for that. If you have any questions, then you can send me an email or you can join the TA. You can ask TAs or you can join my office hours on the Zoom. Good luck.